good evening, and welcome. Wherever you are as you listen tonight, and however you came to be here, in this quiet corner at the end of the day, I'm so glad you've joined me. Maybe you're already tucked into bed, with the covers drawn up, and the room gone dim. Maybe you're lying in the dark after a long and tiring day, or resting somewhere far from your own bed, in the small hours when almost everyone else has gone to sleep. Before we begin, I'd love to know one little thing. Where in the world are you listening from tonight? If you feel like it, leave a short note below to say hello and tell us where you are. There's something quietly lovely about the thought of so many people scattered all across the world, all settling down beneath the same dark sky at once. And if these calm recordings help you unwind and drift off at the end of the day, a gentle like and a quiet subscribe help this little channel more than you'd think. Now let me tell you where we're going to wander this evening. Tonight, we're going to talk about a machine, but not an ordinary machine, and not a cold or noisy one. We're going to talk about the great golden eye that we lifted up above the world, so it could look out into the dark and see farther than anything human beings have ever built before. It is called the James Webb Space Telescope, and it sits right now, this very night, 1,000,000 miles from where you're lying, drifting quietly through space, gathering the faintest light in the universe. We'll follow its whole story. Why we needed it, how we built it, how it unfolded itself far from home like something out of a dream, and what it has begun to show us about the oldest stars, the first galaxies, the places where new worlds are born, and the air around planets that circle other suns. There's nothing here you need to follow closely. There's nothing to study, nothing to remember, and there's certainly no test at the end. If anything, I hope this feels less like a lesson and more like a slow, unhurried story told in the dark, about a wonderful thing that a great many people made together, and about the light it has been quietly catching for us out at the edge of everything. And if you find yourself drifting off to sleep somewhere in the middle, long before we reach the end, please don't feel you've missed a thing. Drifting off is exactly what this is for. So make yourself as comfortable as you can, sink a little deeper into the pillow, let your shoulders soften, and let your eyes close whenever they'd like to. Take one slow breath in and let it gently out. And let us begin, not out in space but here, with something as simple and as ordinary as the trouble with seeing. Let us start with your own eyes, resting closed now in the dark. They are, in their quiet way, remarkable things. All day long they gather light, the light bouncing off faces and streets and the pages of books, and turn it into the whole seen world. But your eyes, for all their gifts, are small, and they are gentle, and there is only so much they can do. On a clear night, when you tip your head back and look up, you can see a scattering of stars, a few thousand at most, faint pricks of light in the dark. And that is very nearly the limit of what a human eye, on its own, has ever been able to reach. The trouble is that most of the universe is simply too faint and too far away for an eye like yours to catch. A star is a sun, blazing with light, but set it far enough away and its light spreads out and thins as it crosses the dark, until by the time it reaches you, only the very faintest trickle is left. Far too little for your eye to notice. And the things we most want to see, the distant galaxies, the newborn stars, the far edges of everything, are fainter still, so dim that their light, after its long journey, arrives as barely a whisper. To catch a whisper like that, you need something larger and more patient than an eye. You need a bucket for light. That when you strip away all the cleverness is really all a telescope is. It is a bucket for light. the wider you make the opening, the more of that thin, faint, far-off light you can gather and gently pour together into a single bright point. A large telescope catches far more light than your eye, and so it can see things far too faint for you ever to notice on your own. And here is the part that is easy to forget and quietly wonderful once you do. When you look at something very far away, you are not seeing it as it is now. You are seeing the light that left it long ago, light that has been traveling toward you all this time. Light is quick, quicker than anything, but it is not infinitely quick. It takes time to cross the great distances of space. So the farther out you look, the further back in time you see. Look far enough, and you are looking at the deep past, at light that set out on its journey before there was an earth, before there was a sun. There is a second gift that a larger mirror brings, beyond simply gathering more light, and it is worth a moment because it matters just as much. A bigger mirror does not only see fainter things, it also sees them more sharply. With a small eye, two stars sitting very close together in the sky blur into a single smudge, and the fine details of a distant galaxy melt away into a soft, shapeless glow. But widen the mirror, and those blurred smudges slowly begin to separate into their true shapes. The single point resolves into two stars sitting side by side. The soft glow resolves into arms and knots and lanes of dust. A great mirror is a little like a pair of eyes that can read the small print of the sky. Print that a smaller eye can only ever see as a haze. So when you build a mirror wider than any telescope we had ever flown in space before, you gain twice over. You catch far more of the faint old light, and you see it far more sharply, fine enough to pick out details in galaxies so distant that they had always been the merest specks. This is the great gift a telescope offers, and the great longing behind building a better one. If we could only build an eye large enough and sharp enough, we could gather the oldest, faintest light there is, light that has been traveling toward us since almost the very beginning of everything, and we could see, with our own instruments, what the universe looked like when it was young. But there are troubles in the way. Two of them, in particular, stand between us and that oldest light, and they are worth understanding, because everything about the strange and beautiful telescope we're going to follow tonight was shaped by the need to get around them. The first trouble is the air, that thin, precious blanket of air that wraps our whole world. The air you are breathing softly in and out right now is a wonderful thing to live inside, but it is a poor thing to look through. It is never quite still. It shifts and shimmers and moves in slow, warm currents, and starlight passing down through it gets bent and jostled along the way. That is why the stars seem to twinkle. It looks pretty from the ground, but to a telescope trying to see something clearly, that twinkle is a blur, a trembling of the whole picture that smears the finest details away, and the air does something worse than blur. It quietly swallows certain kinds of light altogether, soaking them up before they ever reach the ground, so that some of the very light we most want to catch never makes it down to us at all. To get past the air, there is really only one answer. You have to go above it. You have to lift your telescope up out of the atmosphere entirely, into the clear and steady dark of space, where nothing shimmers and nothing blurs and nothing is swallowed on the way in. And the second trouble is stranger, and to understand it we need to talk, gently and without any jargon, about a kind of light your eyes cannot see at all. That is where we're going next. Here is something that sounds impossible when you first hear it, and is entirely true. There is light all around you, right now, in this dark room, that your eyes simply cannot see. Not because it is too faint, because it is the wrong kind. Your eyes were built to catch one narrow band of light, the band we call visible light, the reds and oranges and yellows and greens and blues that make up every color you have ever seen. But that band is only a small slice of something much wider. On one side of it, just past the deepest red your eye can manage, the light carries on, in a form your eyes have no way to notice. We call that light infrared, and the loveliest way to think of it is this. Infrared is the light of warmth. It is the light that warm things give off. You already know this light, even if you have never seen it, because you feel it all the time. Hold your hand near a warm cup of tea, not touching it, just near, and feel that soft glow of heat reaching across the gap to your skin. That is infrared light, traveling from the warm cup to your hand. Stand near a fire or near a wall that has soaked up the afternoon sun and feel the warmth coming off it. That warmth, arriving without touch, is light, real light, the same kind of thing as the glow of a lamp, only pitched too far into the red for your eyes to catch. Every warm thing gives it off. Your own body is glowing with it this very moment, a soft, steady shine of warmth that special instruments can see in the dark. We simply cannot see it ourselves, but we can build eyes that can. And when you build an eye that sees warmth instead of ordinary color, the whole universe opens up in a way it never could before, for two beautiful reasons. You may have met this hidden light already, in small everyday ways, without ever thinking of it as light at all. The little remote that changes the television speaks in a beam of infrared, flashing a silent message your eyes cannot see across the room. The night vision cameras that let people see in the dark work by catching the infrared glow of warm bodies and warm ground, painting a picture out of heat where there is no ordinary light to be had. Even the warmth you feel on your cheek from a radiator across the room is this same light, crossing the space between and touching your skin. It has been here all along, this quiet light of warmth, woven right through your ordinary days, and we simply never had eyes for it. It turns out, too, that visible light and infrared are only two neighbors in a whole long family of light that stretches away in both directions, most of it invisible to us, all of it the same sort of thing, only pitched higher or lower than our eyes were ever built to catch. Infrared is the near neighbor just past the red, the light of gentle warmth, and it happens to be exactly the neighbor we most need for looking deep into space. The first reason takes us back to that oldest, faintest light we were longing to catch, the light from the very first galaxies at the edge of time. When that light first set out, all those billions of years ago, it was ordinary light, much like the light of any star, full of the colors your eyes know. But something happens to light on a journey that long, and it is one of the quietest, most surprising truths in all of science. Space itself, the great emptiness between the galaxies, is very slowly stretching. It has been stretching ever since the beginning, growing wider and more spread out with every passing age. And as that space stretches, the light traveling through it gets gently stretched along with it, its waves drawn out longer and longer over billions of years. Light stretched like that slides down the scale, away from blue, down through red, and finally right off the edge of what your eyes can see into the infrared. So the light from the most distant, most ancient galaxies, the light that has been traveling the longest, does not arrive as visible light at all anymore. It arrives as warmth. It arrives as infrared. And that means the only way to see the earliest things in the universe, the only way, is with an eye that can see heat. The second reason is closer to home, and just as lovely. Out among the stars, there are great clouds of dust and gas, huge and cold and dark, and it is inside these clouds that new stars are born. But ordinary visible light cannot get through them. The dust blocks it, the way a thick fog blocks the light of a distant lamp, so that with ordinary eyes and ordinary telescopes, the nurseries where stars are being made are hidden from us behind a curtain we cannot see past. Infrared light, though, the light of warmth, slips through that dust far more easily. It passes through the fog where visible light gets stopped. So an eye that sees warmth can peer straight into those dark clouds and watch the newborn stars glowing inside, in places that had always been closed to us before. To see the birth of stars, and to see the birth of the universe itself, you need the same thing. You need a telescope that sees heat, and that is exactly what we built. Now let us look at the telescope itself, and at its heart, which is its mirror. Because for all the wonders inside it, a telescope like this one is really built around a single, simple job. Catch as much faint light as you can and bring it gently to a point. And the way you catch light in a great telescope is not with a lens, like the glass in a pair of spectacles, but with a mirror, a wide, curved, beautifully polished mirror that gathers the light falling onto it and reflects it all inward to one place. The rule of the whole thing is easy to feel. The bigger the mirror, the more light it catches, and the fainter and farther the things it can see. So if you want to see the oldest, dimmest light in the universe, you want the biggest mirror you can possibly build. And the mirror at the heart of this telescope is very big indeed. It measures about 6.5 meters across, which is wider than most rooms in most houses. A great dish of a mirror taller than the tallest person you know, standing on its end. To gather the faint light of the first galaxies, you need a bucket for light that wide. But a mirror that big brings a problem all its own, and it is a very practical one. There is no rocket with a nose cone wide enough to hold a mirror 6.5 meters across in one solid piece. It simply would not fit. And so the people who built this telescope did something wonderfully clever. Instead of one huge mirror, they made the great mirror out of smaller pieces, 18 of them, each one shaped like a hexagon, a 6-sided tile, so that they could be fitted together edge to edge, with no gaps, like the cells of a honeycomb, into one large mirror with a gentle curve. Each of those 18 pieces is about the size of a small coffee table, and together they form the wide golden dish that does all the seeing. And because the mirror is made of separate tiles, it can be folded. The outer tiles are set on hinges so that they can be tucked in for the journey and then opened out once the telescope is safely in space. We will come to that unfolding soon, because it is one of the most nerve-wracking and beautiful parts of the whole story. But for now, simply picture that great honeycomb of 18 pieces made to fold like a flower closing up at night. Now, why golden? This is my favorite small detail in the whole design, and it is entirely real. Each of those 18 mirror segments is coated in a layer of actual gold. Real gold, the same metal as a wedding ring, laid over the mirror in a film so thin it is hard to believe. The whole coating is only about 100 nanometers thick, which is a way of saying almost impossibly thin, something like 1,000th of the thickness of a single sheet of paper. If you spread all the gold on the whole enormous mirror out into a single lump, it would come to only about the weight of a golf ball. And yet that whisper-thin skin of gold is not for beauty, though it is beautiful. It is there for a reason that ties the whole story together. Gold, it turns out, is a wonderful mirror for infrared light. It reflects that light of warmth better than silver, better than almost anything, throwing back very nearly every bit of infrared that falls upon it. Since this is a telescope built to see warmth, its mirror is dressed in gold, the metal that reflects warmth best. There is a quiet cleverness, too, in what the mirror is made from, underneath its skin of gold. The tiles are not glass, as you might expect a mirror to be. They are cut from a light, silvery metal called beryllium, and it was chosen for a particular reason. Out where the telescope lives, in that deep, cold, ordinary materials shrink and warp as the temperature falls, and a mirror that changed its shape even slightly in the cold would blur everything it tried to see. But beryllium holds its shape faithfully once it is cold. Barely stirring, however, the chill deepens, and it is remarkably light for its strength, which matters greatly when every last bit of weight must be lifted off the earth. So each tile was carved from this steady, featherweight metal, its back hollowed out into a fine honeycomb pattern to make it lighter still, then polished smooth and dressed in gold. Light, steady, and true, even in a cold near the very bottom of all cold. And the great dish is not quite the whole of it, for a mirror on its own does not make a picture. When the faint starlight falls onto the wide golden honeycomb, it is all reflected inward and forward, gathered toward a single point out ahead of the telescope. There, waiting to catch it, is a second, much smaller mirror, held out in front on 3 long, thin arms, and also faced with gold. That small mirror takes all the gathered light and throws it back again, down through a gap in the very center of the big mirror, to the instruments waiting quietly behind, in the cold heart of the telescope. And it is those instruments, tucked in the dark behind the mirror, that do the real work of turning the light into pictures, and into the jagged little readings of color we'll come to later. So the light's path is a patient one, in off the wide golden dish, forward to the little mirror out front, back through the middle, and home at last to the waiting instruments, every step of the way guided by gold. So there it is, the heart of the telescope, a wide dish of a mirror, 6.5 meters across, built from 18 hexagonal tiles fitted together like a honeycomb, folding like a flower, and every face of it gleaming with a coat of real gold, thinner than you can imagine. All of it made to catch the faintest, oldest, warmest light there is, and pour it gently inward. It is one of the most carefully made objects human hands have ever produced. And once it was finished, and folded up small, it had to be lifted off the earth and sent 1,000,000 miles away, and unfolded, all on its own, in the dark, with no one there to help it. That is where we go next. On a winter morning, at the very end of the year 2021, on the 25th of December, the folded-up telescope was placed on top of a rocket at a launch site near the edge of the great forests of South America, in a place called French Guiana, and lifted off the earth. It rose up on a pillar of fire, up through the clouds and up through the thinning air, up past the blur and shimmer of the atmosphere we talked about, until it was out in the clear black quiet of space. And then the rocket let it go, and the telescope was on its own, coasting silently outward, away from the world, toward a place 1,000,000 miles from home. But here is the thing to understand. And it is what made those next weeks so tense for everyone who had worked on it. The telescope that left the Earth did not look like a telescope at all. It was folded up tight, packed into the smallest bundle they could manage so that it would fit inside the rocket. The great golden mirror was folded in on itself, its side pieces tucked back. The sun shield, the huge shade that would keep it cold, was wrapped and pinned into a small, flat package. Everything was clipped and pinned and stowed. And now, out in space all alone, it had to unfold itself. Piece by piece, over about 2 weeks, it had to open out into its full shape, unpacking itself in the dark with no human hand anywhere near it to guide it, or nudge it, or fix it if anything went wrong. And that is the heart of why this was so frightening. This telescope was not going to circle close to the Earth, the way some telescopes do, near enough that people might one day fly up to repair them. It was going 1,000,000 miles out, far beyond the reach of anyone. No one was ever going to visit it, so every single one of those unfolding steps had to work the first time, perfectly, with no second chances and no one to help. Engineers had a plain and rather sobering way of counting the risk. They spoke of the single points of failure, the individual steps where, if that one thing jammed or snapped or failed to catch, the whole mission could be lost. And in this unfolding, they counted about 344 of them. 344 separate moments, each of which simply had to go right. Pins that had to release, latches that had to lock, cables that had to pull taut, motors that had to turn, panels that had to swing into place and hold. Any one of them, failing, might have meant the end. So you can imagine the quiet in the control rooms back on Earth, and the held breath, as day by day the commands went out, and everyone waited to learn whether, 1,000,000 miles away, in the dark and the cold, the telescope had done as it was asked. The very first step came only minutes after the telescope parted from the rocket, when it unfolded the panel that would drink in sunlight and give it power, for without that, it could do nothing at all. That one worked, and a small cheer must have gone up. Then, over the following days, one careful move at a time, it swung out the 2 long arms that would carry the shade, and lowered the flat pallets that cradled the folded layers, and began the slow, delicate business of pulling those 5 thin films apart and drawing each one tight. That tensioning alone took days, and it was the part that had kept engineers awake at night for years, because the films were so very thin and so easily snagged. Each layer had to be coaxed free and stretched flat in its turn, in the cold and the silence, with tiny motors reeling in cables inch by careful inch. Day by day the reports came back that another step had held, and then another, and the hell breath on Earth grew a little easier each time. And slowly, over those 2 weeks, it did. First came the hardest and most complicated part, the great shade. Over several days it unpacked its 5 wide layers, swinging out the arms that held them, and then, most delicately of all, pulling each thin layer apart from the others and drawing it tight and flat, one after another, until the whole shade stood open, wide as a tennis court, floating in the dark. This was the part that had worried people most, because it had so many separate steps and so much thin, delicate material that had to pull free cleanly without snagging or tearing. And it worked. Then, once the shade was open, the telescope began to open its eye. The secondary mirror, a smaller mirror held out in front on 3 long arms, unfolded and locked into place. And then, at last, the great golden mirror itself. The side panels that had been folded back swung slowly open, one and then the other, and clicked into position, and the honeycomb was whole. The flower had opened. I find it a genuinely moving thing to picture, even now. A machine entirely alone, further from home than almost anything we have ever built, quietly unpacking itself in the dark, one careful step after another, with a whole world of people watching from 1,000,000 miles away and unable to do anything but hope. There was no drama out there, no sound, no rush, only slow, patient motion in the silence and the cold, as the thing we had made unfolded itself exactly as it was meant to, and became, at last, a telescope. And when the final latch had locked and the last panel was in place, all 344 of those anxious steps behind it, there must have been a feeling back on Earth that is hard to put into words. Relief and wonder, and something close to disbelief that it had truly actually worked. While all that unfolding was going on, the telescope was still moving, drifting steadily outward, away from the Earth, toward the particular spot in space where it was always meant to live. And that spot is worth talking about slowly, because it is a strange and clever choice, and it explains a great deal about how the telescope is able to do what it does. Most telescopes we send up stay close, circling the Earth again and again, only a few hundred miles above the ground. This one went much, much farther. Its home is about 1,000,000 miles away from us, which is roughly 4 times as far as the Moon, out in a direction pointing straight away from the Sun. In the older way of measuring, that is around 1.5 million kilometers. It is genuinely far. If the Earth were a small ball you could hold in your hands, the Moon would be a smaller ball a little way across the room, and this telescope would be sitting 4 times farther still, out past it in the dark. That is where it lives now, and where it will stay. But why there? Why send it so far, to a spot that seems like nothing in particular? Just empty space 1,000,000 miles out. The answer has to do with a lovely hidden feature of that exact place. As you know, the Earth is always circling the Sun, held in its path by the Sun's gravity, that same quiet pull that keeps your feet on the ground. And the Moon circles the Earth. Everything is always being tugged and pulled. But there are a few special spots in the neighborhood of the Earth and the Sun, where all these pulls happen to fall into a gentle balance, places where an object can settle and keep pace with the Earth as it goes around the Sun, staying in the same relative position year after year, instead of drifting away or falling behind. Scientists call these the balance points, or, by a more formal name, the Lagrange points, after the man who first worked out that they must exist. And the one this telescope uses, out on the far side from the Sun, is the second of these balance points. It is the perfect parking spot in space. Once you settle a telescope there, it will happily travel along with the Earth, keeping station 1,000,000 miles out, needing only the smallest occasional nudge to hold its place. It does not sit perfectly still at that balance point, mind you. It traces a wide, slow loop around it, a great lazy circle out in the empty dark that takes about half a year to travel around once, drifting gently out to one side and back again, never quite settling on the exact spot, but always staying near it. This slow looping keeps it in a good position to see the sky and to speak with the Earth, and it costs almost nothing to maintain. Every so often, the telescope gives itself the tiniest push with a puff of fuel, just enough to keep from drifting away, and then it coasts on. It carries only so much of that fuel, of course, and when at last it runs low, many years from now, it will slowly wander from its post and its long watch will come to an end. But there is a great deal of fuel aboard, more than was feared at first, thanks to a very gentle and accurate launch that saved much of it. And so the telescope should be able to keep its station for many years yet, far longer than it was ever promised to last. And though it is so terribly far away, we are not out of touch with it. Through a great dish antenna on its warm side, the telescope speaks to the Earth by radio, sending home the light it gathers as long streams of numbers, and listening for our instructions in return. Those messages are themselves a kind of light, and even light, quick as it is, takes a few seconds to cross that million-mile gap. So there is always a small delay, a handful of seconds each way, between a command leaving the Earth and the telescope receiving it. There is something almost tender in that little pause. We cannot reach out and touch the thing we made. We can only send our careful words across the dark and wait the few seconds for them to arrive, and then wait again for word to come back that it has done as we asked, out there alone at the far edge of the Earth's long reach. And there is a second reason that spot is so perfect, and it is the deeper one. Out there, a million miles away in that particular direction, the sun and the Earth and the moon are all gathered together on the same side of the sky, all bunched up behind the telescope. From out there, they crowd into one small region of the view, all in roughly the same direction. And that is exactly what this telescope needs, because it means it can turn its back on all three of them at once. It can face out into the deep dark, away from the sun, away from the Earth, away from the moon, and hold a single great shade up between itself and all of them, keeping every one of them behind it and blocked out together. If it circled close to the Earth instead, the sun and the Earth would keep swinging around into its view from different sides, warming it and lighting it and getting in the way. Out at that far balance point, everything bright and warm stays neatly behind it, in one place, all the time. And that is precisely what lets it stay so dark and so cold, which, as we're about to see, is the whole secret of how it sees. We have said more than once now that this is a telescope built to see warmth, to see the faint infrared glow of the oldest and coldest and most distant things in the universe. And that gift carries with it a strange and demanding difficulty, one that shaped almost everything about the way the telescope is built. If your instrument is trying to see the faint warmth of distant things, then the instrument itself must not be warm, because if it were, its own heat would drown out everything it was trying to see. Think of it this way. Imagine you are trying to listen for the softest, most distant whisper, the faintest sound at the very edge of hearing. You could never do it in a noisy room. You would have to make everything around you utterly silent first, so that the tiny far-off whisper could be heard at all. Warmth, for this telescope, is exactly like that noise. Every warm object glows in infrared, remember. If the telescope itself were warm, it would be glowing softly in the very same light it was trying to catch from the distant universe. And its own glow would flood the picture and wash the faint far-off light away completely. It would be like trying to see a candle across a field while holding a lantern up to your own face. So there is only one answer: to see the cold, faint warmth of the far universe. The telescope must itself be made colder than almost anything, so cold that it barely glows at all. And here is where that great shade comes in, the one we watched unfold so anxiously in the dark. Its whole purpose is to keep the telescope cold by keeping it in shadow, permanently, forever. It is called a sunshield, and it is enormous, about the size of a tennis court, a wide flat shade held out between the telescope and the sun. It is made of 5 separate layers, each one thinner than a human hair, stretched out with small gaps between them, and it works beautifully. The side that faces the sun catches all that heat and light and gets fiercely hot, hotter than boiling water. But layer by layer, the heat is turned back and bled away into space through the gaps, so that by the time you reach the 5th layer, on the shaded side where the telescope lives, almost none of that warmth is left. One side of the shade roasts in the full glare of the sun. The other side, only an arm's length away, sits in the deepest cold. It is a little like standing in the shade of a single wide umbrella on a blazing day, except that this shade is so good that it turns a scorching sunlit place into one of the coldest places we have ever made. And the shade divides the whole telescope into 2 worlds, a hot side and a cold side, that must never mix. On the warm, sunlit side ride, the things that do not mind a little heat, and even need it. The panels that drink in sunlight and turn it into power. The little dish that speaks to the earth. The computers and the machinery. All the busy, warm running parts. All of them kept over on the sunny side of the shade. And on the cold, shadowed side, alone in the dark, sits the telescope itself, the golden mirror and the delicate instruments, kept far away from all that warmth, so that not a breath of the machinery's heat can reach them. It is a bit like a house built with the furnace on one side of a very good wall and a cold larder on the other, except that here the wall is only 5 wisps of shining film, and the 2 sides are as far apart in warmth as almost any 2 places we have ever set side by side. What I find lovely about all this is how simple the trick is underneath. There is no great roaring machine doing the cooling, for the most part. The telescope grows cold, mostly by being left alone in the shade, turned away from every source of warmth, allowed to shed its heat quietly into the endless cold of space until there is almost none of it left. Space itself is the coldest thing there is, and if you can only keep the sun and the earth from shining on you, space will cool you all the way down for free, patiently, asking nothing in return. That whole wide shade exists simply to make that possible, to hold off the warmth of the sun, so that the deep cold of space can do the rest. It is cleverness, in the end, in the service of stillness. So how cold does the telescope become, tucked in that permanent shadow, out in the dark, a million miles from home? It cools down to somewhere around -230 degrees on the Celsius scale. That is a cold, almost past feeling, far colder than the coldest winter night that has ever fallen anywhere on Earth, far colder than the deepest polar ice. It is only a little way above the coldest that anything can ever possibly be, a limit that sits at around -273 degrees, the very bottom of cold, where all warmth runs out entirely. The telescope hangs there in the dark, chilled to within a stone's throw of that final cold, so still and so cold that it barely glows at all, and its infrared eyes can open onto the universe and catch the faintest warmth without being blinded by their own. And one of its instruments, the one that looks deepest into the infrared, has to be colder still, cooled by a special machine down to only about 7 degrees above that final cold, colder than the rest of the telescope, colder than nearly anywhere in the known universe outside of a laboratory. All of that, all that trouble and cleverness, simply to keep the instrument quiet enough, dark enough, cold enough, to hear the faintest whisper of light from the beginning of time. For half a year after it arrived at its cold, dark home, the telescope was not yet ready to work. There was a long, patient season of getting everything just right. The 18 golden pieces of the mirror had to be nudged and adjusted, each one by tiny amounts, until all 18 were aligned so perfectly that they acted as a single flawless mirror, all their light brought together to precisely the same point. This was delicate, careful work, done from the ground a million miles away, tuning each segment by movements finer than the width of a hair. The instruments had to cool fully and settle. Everything had to be tested and checked. And then, at last, in the summer of 2022, on the 12th of July, the world was allowed to see what the telescope had begun to see, and it took people's breath away. The very first picture they shared was the deepest of them all, and to my mind, still the most staggering. It was a single photograph of a small patch of sky, and I want you to understand just how small a patch. Hold a single grain of sand up at arm's length against the night sky. The little scrap of sky that grain would cover, that tiny, tiny speck of the whole dome above you, is all this picture showed. A piece of sky you would have said was empty, hardly worth pointing anything at. And in that one grain of sand patch, the telescope found thousands of galaxies. Not stars, galaxies. Each one a whole island of hundreds of billions of stars, like our own Milky Way, and there were thousands of them crowded into that one tiny speck of sky, glittering back through the dark. Some of them shone as they had looked long, long ago, their light having travelled for many billions of years to reach the telescope's golden eye. It was the deepest, sharpest look into the distant universe anyone had ever managed, and it came from a patch of sky the size of a grain of sand. If that is what hides in one tiny speck, then the whole sky, in every direction, is quietly full of galaxies beyond any counting. And that deep picture, for all it showed, was gathered in less than a single day of looking. The telescope stared at that one grain of sand patch of sky for something under half a day, patiently drinking in every faint speck of light that fell from it, and that was enough to reach farther and see fainter than the older great telescope had managed in many days of staring at a similar patch of sky. That is the difference a wide golden mirror, out in the cold and the dark, can make. What had taken the eye before it long, long stretches of looking, this one could do in an afternoon, and go deeper still. One gentle thing is worth knowing about all these pictures, so they don't mislead you. The telescope sees in warmth, in infrared, in light our eyes cannot see, and so, strictly speaking, its pictures have no colours of their own that a human eye could ever have witnessed. What the people who work with the telescope do is translate. They take the different shades of infrared the telescope catches and gently give each one a colour our eyes can see. The shortest infrared painted blue, the longest painted red, and the ones between shaded across the rainbow in order. So the glowing golds and deep reds and soft blues of those famous pictures are true to what the telescope truly measured, faithful maps of its infrared light, but they are a kind of loving translation, turning warmth into colour so that we can look upon it with our own eyes. It is a little like someone describing a piece of music to you in words. Not quite the thing itself, but an honest and careful rendering of it, made so that you can share in what the instrument perceived. The other first pictures were just as lovely, each showing off a different thing the telescope could do. There was a great cloud where stars are born, a place with a name as beautiful as the picture, the cosmic cliffs, part of a larger cloud called the Carina Nebula. It looked, in the telescope's infrared eyes, like a range of golden mountains and cliffs made of glowing gas and dust, with a fine mist rising off their peaks, and set against them a whole sky sprinkled with stars, many of them brand new, so young they had never been seen before, still half wrapped in the dust that made them. The telescope had looked straight through that dust, the way only an eye for warmth can, and found the newborn stars hiding inside. When the telescope looks into one of these clouds, it sees things a gentler eye would miss entirely. It sees narrow jets of gas shooting out from some of the very youngest stars, flung off from their poles in thin bright streamers as the new star gathers itself and spins, ploughing into the surrounding cloud and lighting it up as they go. It sees tall pillars and towers of dense dust, sculpted into strange and lovely shapes by the winds and the light of the stars nearby, slowly being worn away like sea cliffs under a tide, with fresh new stars forming in their shadowed hollows, even as the pillars themselves dissolve. And it sees the whole cloud glowing softly in colours that stand for warmth and for the particular gases within it, so that what looks to us like a plain photograph is really a careful map of temperature and substance, showing where the cold, dense knots are that will one day become stars, and where the warm, thin gas is quietly drifting away, all of it caught by an eye patient enough and cold enough to read the faint warmth of a cloud that would otherwise be simply dark. There was a picture of a little group of 5 galaxies clustered together in the sky, 4 of them caught in a slow and graceful dance, drifting close and pulling gently on one another, with their gravity over unimaginable stretches of time, their shapes drawn out into long streaming arms as they slowly wheel around each other. There was a picture of a dying star, an old sun near the end of its life, that had puffed off its outer layers into a great glowing ring of gas, soft rings and shells of light, spreading gently outward into the dark, a quiet and rather beautiful image of an ending, the kind of ending our own sun will come to in the far, far future. And there was one picture that did not look like a picture at all, and it was, in its way, the most remarkable of them. It was a spectrum, a reading of the light from a planet going around another star, far off in the galaxy. And in that jagged little line of light, the telescope had read something extraordinary. It had found the fingerprint of water vapor in the air of a world circling a distant sun. We will come back to how it can possibly do such a thing, because it is one of the most wonderful tricks in the whole story. But that is how the telescope announced itself to the world. Thousands of galaxies in a grain of sand, mountains where stars are born, a slow dance of galaxies, the soft ring of a dying star, and water in the air of another world, all in a single day. Of everything this telescope was built to do, there was one dream that stood above the rest, and it is the one we touched on right at the start. To look back, farther than anyone had ever looked, toward the very beginning, and to see the first galaxies as they were forming, when the universe was young. And in this, more than anywhere, the telescope has been doing exactly what it was made for. Let me set the scene as gently as I can, because the numbers are large and I don't want them to feel cold. As best we can tell, the whole universe is about 13.8 billion years old. That is the span of time back to the very beginning, to the moment everything we know began to expand out of a hot, dense start. For a while after that beginning, there were no stars and no galaxies at all. Only a thinning fog of gas spreading out in the dark, slowly cooling. And then, Sometime in the first few 100 million years, in the deep early dark, the very first stars began to light up, and the first small galaxies began to gather. That is the moment we most wanted to see, the dawn of everything, the first lights coming on. It is worth pausing on how strange and different that early time was when these first galaxies were shining. There were no planets like ours yet, and there could not have been, because the very stuff that planets and people are made from, the iron and the carbon and the oxygen, did not exist at the beginning. The early universe held only the two lightest, simplest materials there are, and everything heavier had to be forged later, cooked in the hot hearts of the stars themselves, and then scattered out across space when those stars died, to be gathered up into the next generation. So the first galaxies were simpler places, made of the plainest ingredients, and their stars may well have been larger and hotter and shorter lived than most stars are today. By looking at them, the telescope is not only seeing the past, it is watching the very beginning of the long process that, over billions of years, would slowly enrich the universe with the makings of worlds, and in the end, of us. Every heavier thing in you, the iron in your blood, the calcium in your bones, was cooked inside stars that lived and died long after these first galaxies lit up, in the great unfolding that they began. And because looking far away is the same as looking back in time, seeing that first dawn means catching light that has been traveling toward us for almost the whole age of the universe, well over 13 billion years. It is the oldest, faintest, most stretched out light there is, stretched so far by the long expansion of space that it arrives entirely as infrared, as warmth. Which is precisely why we needed a great cold golden eye for warmth to catch it at all. No telescope before this one could reach that far or see that light. This one can. And when it turned its eye toward the deep field and looked, it began to find them. The early galaxies, small, faint, glowing red with their stretched and ancient light. Galaxies as they were when the universe was only a few 100 million years old, a small fraction of its age now, when everything was newly made and the first stars were young. The telescope keeps finding them farther and farther back, and the record for the most distant galaxy has been broken again and again. As things stand, the farthest one confirmed so far is a small galaxy whose light set out toward us when the universe was only around 300 million years old, less than 300 million years after the very beginning. Think of what that means for a moment, quietly. The light now falling into that golden mirror, 1,000,000 miles above your head, left that little galaxy more than 13 billion years ago, before the Earth existed, before the Sun existed, before there was anything here at all, and it has been crossing the dark, patiently, all that time, only to be gathered in at last by a mirror we folded up and sent into space. When the telescope looks at that galaxy, it is not seeing something old and faded. It is seeing something young, a small, bright galaxy in the freshness of the early universe, full of new stars, caught in the act of being one of the first. We are, in the most literal way, watching the dawn. You might wonder how anyone can be sure that a little smudge of light is truly so far away and so old, rather than something dimmer and nearer. The answer goes back to that stretching of light we spoke of earlier. The farther the light has traveled, the more the long expansion of space has stretched it along the way, and so the more its colors have slid toward the red, and beyond the red, into the infrared. By spreading a galaxy's light out and measuring just how far it has been shifted, how far it has slid down toward the warmth end of things. The telescope can read off, with real confidence, how long that light has been on its way, and so how far off, and how far back in time, the galaxy must lie. The most distant galaxies show the greatest shift. Their light stretch the most of all. That stretch is the measure of their age. It is a little like telling how long a traveler has been walking by how worn their shoes have become. The light arrives, and it carries within its own stretched colors the quiet record of the immense journey it has made to reach us. And I should say, honestly and gently, that what the telescope found out there has surprised the people who study it, and in a way that is still being puzzled over tonight. Some of these very early galaxies looked bigger and brighter and more grown up than anyone expected them to be so soon after the beginning. The best ideas we had about how quickly galaxies could gather and grow did not quite predict that there would be such well-developed galaxies so early. This is not a crisis, and it is certainly nothing to worry over as you rest. It is the ordinary, wonderful way that science moves forward. A new eye sees something unexpected, and the people who think about these things gather round and begin, slowly and carefully, to work out what it means, and to adjust their understanding of how the first galaxies came to be. Perhaps stars form faster in the early universe than we thought. Perhaps the earliest galaxies shone more brightly, for reasons we are only beginning to guess at. Nobody yet knows for certain, and that not knowing is exactly the sort of open and hopeful mystery that a great telescope is supposed to hand us. We built an eye to see the dawn, and it showed us a dawn a little different from the one we imagined. And now we get to find out why. Let us come back now, from the far edge of time, and turn to something closer and gentler, though no less wonderful. For the same eye that can see the first galaxies at the beginning of everything can also turn to the clouds much nearer home, here in our own galaxy, and watch stars being born tonight. And this is one of the things it does most beautifully. Stars are not eternal, and they are not always there. They are born, they live out their long lives, and in time they die, and new ones are always being made. And the place they are made is inside those great dark clouds of gas and dust that drift between the stars. The same clouds we talked about, the ones that ordinary visible light cannot see through. These clouds are huge and cold and quiet, and for the most part nothing much happens in them for a very long time. But here and there, a patch of the cloud grows a little denser than the rest, and its own gentle gravity begins to pull it inward, drawing more gas toward it and more, so that the patch grows thicker and heavier and starts to fall together in on itself. And as all that gas crowds inward and packs down tighter and tighter, the very heart of it begins to warm, and then to glow, and at last, when it is dense and hot enough at its core, it catches light, and a new star begins to shine. It is the same slow gathering that made our own sun, long ago, out of just such a cloud. The trouble, always, was that this happens deep inside the dust, hidden away where we could not watch. The newborn star is wrapped in the very cloud that made it, buried in dust, so that with ordinary telescopes we could only see the outside of the cloud, a dark shape against the stars, and never the birth going on within. But now we have an eye that sees warmth, and warmth passes through the dust. So this telescope can look straight into those clouds, past the curtain of dust that always hid them, and see the young stars glowing inside, still swaddled in the gas and dust they were born from. That is what those golden mountains in the cosmic cliffs really were. Not mountains at all, but the edge of one of these great star-forming clouds, lit up and shaped by the young stars nearby, with countless newborn suns scattered through it, many of them revealed for the very first time by an eye that could see through the dust to find them. And there is more than just the stars in these pictures, because the telescope has been catching sight of something even more tender. Around a great many of those newborn stars, it can see thin, flat disks of leftover dust and gas, spread out around the young star like a wide, faint plate. And those disks are where new worlds come from. It is out of exactly such a disk, circling a young star, that planets slowly gather, the dust clumping together over long ages into pebbles and boulders, and at last into whole planets, in just the way our own Earth once formed around the young sun. So when the telescope looks into these nurseries, it is not only seeing stars being born, it is very likely seeing the raw beginnings of planets too, whole solar systems in their earliest infancy, the first faint stirrings of worlds that may exist billions of years from now. There is something quietly comforting in that, I think. It means that what happened here long ago, the making of our sun and our earth and everything on it, is happening still, out there in the dark, over and over, in cloud after cloud across the galaxy. New stars and new worlds are being made all the time. And now, at last, we have an eye gentle enough and patient enough to watch it happen. Now let us come back to that strangest of the first pictures, the one that did not look like a picture at all, the jagged little line of light that held the fingerprint of water in the air of a distant world. Because this may be the most astonishing thing this telescope can do, and I want to take it slowly, since it sounds at first like something that ought to be impossible. We have known for some years now that the stars in the night sky are not alone. Most of them, it turns out, have planets going around them, worlds of their own circling other suns, far too far away for us ever to visit, and far too faint and too close to their bright stars for us to see as anything more than, at best, a single dot. So how could you ever hope to learn what the air around such a world is made of? A world so distant that it is lost in the glare of its star? The answer is a beautiful piece of patience and cleverness, and it rests on a bit of lucky good fortune. Some of these distant planets, as they circle their star, happen to pass directly between us and that star, crossing in front of it, over and over, once each time they go around. And when a planet passes in front of its star, something very small and very useful happens. A little of the star's light, on its way to us, does not come straight from the star's surface. It passes first through the thin shell of air around the edge of the planet, filtering through the planet's atmosphere before carrying on across space toward the telescope's waiting eye. And here is the wonderful part. When starlight passes through a planet's air, the different gases in that air each drink up their own particular colors of light and no others. Every kind of gas has its own favorite colors that it absorbs, as unique to it as a fingerprint. Water vapor takes certain colors. A gas like carbon dioxide takes others. And so, when that filtered starlight finally reaches the telescope, some of its colors are very slightly dimmed, missing, drunk up by the air of the faraway world it passed through. By spreading the light out and reading carefully which colors are dimmed and which are not, the telescope can work out, from 1,000,000 miles away, what the air of that distant planet is made of. It never sees the planet as a picture at all. It simply reads the shadow that the planet's air has left in its star's light, and from that shadow tells you what gases are in that far-off sky. This is what that first jagged little line of light really was. It was the shadow of a distant world's air, written in the colors of its star, and in it, plain to read, the unmistakable mark of water. Since then, the telescope has read the air of many such worlds and found real and interesting things. It has found water vapor in some. It has found carbon dioxide, the same gas that fizzes in a bottle of sparkling water, and that we breathe out with every breath, clearly present in the air of a planet around another star. The first time such a thing had ever been seen so plainly. On some of these worlds, it has found signs of clouds and hazes, and even hints of a fine mist of something almost like sand high in a scorching sky. Each of these is a small marvel, a real fact about a real place unthinkably far away, learned by patiently reading a whisper of filtered starlight. Most of the worlds it has read so far are great puffy giants, planets far larger than the Earth, made mostly of gas, circling close into their stars where they are roasting hot. Those are the easiest to read, because they are big and their airs are thick, and so they leave a clear mark in the starlight passing through them. The small rocky worlds, the ones more like our own Earth, are far harder, because they are little, and their airs are thin, and the shadow they leave in the light is fainter by far, right at the very edge of what even this telescope can catch. It has begun to reach toward them all the same, straining to tell whether some small rocky world circling a distant star has any air around it at all. And this is slow, painstaking work, gathering the faint signal over many passes of the planet in front of its star before anything can be said with confidence. It is one of the hardest things the telescope is asked to do, and one of the most patient, and we are only at the beginning of it. And I know the question that sits behind all of this, the one everyone quietly wonders. Could it find life? Could it read the air of some distant world and find, in those dimmed colors, the mark of a living planet, an air stirred and shaped by living things the way our own air is? And the honest answer, the one I want to give you plainly, is that it has not, and that finding such a thing would be enormously hard, and that no one has seen it. What the telescope can do is read the ingredients of these distant airs and look for gases that might, just possibly, be tied to life. But reading a gas is one thing, and knowing what made it is another. And there are almost always ordinary, lifeless explanations to rule out first. So this is a place for real honesty and gentle patience. The telescope has given us the power to sniff the air of other worlds, which is a genuinely new thing under the sun, something no people before us could ever do. Whether it, or the telescopes that come after it, will one day read the air of a living world, no one can say. It is one of the great open questions, held out ahead of us in the dark. And there is something rather peaceful in simply letting it stay a question a little longer, unhurried, unanswered, waiting. Whenever we build a truly new kind of eye and point it at the universe tends to answer with things we did not expect. That has always been the way of it. And this telescope, in its short life so far, has already handed us a whole armful of surprises, gentle puzzles that the people who study the sky are still turning over. I'd like to share a few of them with you, softly, not as worries, but as wonders, because there is a real delight in a universe that can still surprise us. We have already touched on the first and biggest surprise, out at the edge of time. Those early galaxies that looked more grown up, more massive and more bright than our best ideas said they had any right to be so soon after the beginning. When the telescope first found them, there was a flurry of excitement and puzzlement, and some wondered whether our whole understanding of the early universe might need rethinking. As more careful measurements have come in, the picture has calmed a little. Some of those galaxies turned out to be not quite as enormous as they first seemed, and clever new ideas have begun to explain how the early universe might make bright galaxies faster than we thought, without breaking any of the deeper rules. But the puzzle is not fully solved, and that is honest to say. The early universe was busier and brighter than we expected, and we are still working out exactly why. Another surprise has been a scattering of curious little objects the telescope keeps finding in the early universe, very small and very red, that have earned the plain nickname of the little red dots. No one is entirely sure yet what they are. They may be small early galaxies packed tightly with stars. They may hold growing black holes at their centers, feeding and glowing, far earlier and far more commonly than we would have guessed. The truth is still being worked out, patiently, picture by picture, and it may turn out to teach us something new about how the giant black holes at the hearts of galaxies first came to be. For now, they are simply a genuine mystery, freshly discovered, waiting to be understood. There has been another quiet surprise in the very shapes of things. We used to think that neat, orderly galaxies, the graceful spirals with their winding arms, took a very long time to settle into such tidy forms, and that the early universe should be a place of only ragged, clumpy, half-made galaxies still crashing into one another. But the telescope has found calm, well-ordered galaxies, some with the first hints of spiral arms and long bars across their middles, further back in time than we ever thought such tidiness could exist. It seems galaxies grew up and grew orderly, sooner than we imagined. None of this, I should say plainly, has overturned the great outline of the story, the beginning, the long expansion, the slow gathering of galaxies across billions of years. That larger picture stands as firm as ever, tested and confirmed in 100 different ways. What the telescope is changing is the finer detail, the how, and the how quickly of it, filling in and correcting the middle chapters of a story whose broad shape we are fairly sure of. And that is exactly how understanding deepens, not by tearing everything up and starting over, but by gently sharpening the picture, year after year, as a clearer eye brings the small details into view. Closer to home, the telescope has surprised us in gentler ways too. It has looked at the planets of our own solar system with its infrared eye and seen them freshly, catching faint rings around distant worlds and the soft glow of their weather in more detail than we had before. It has peered at moons and found new hints about what lies beneath their icy surfaces. It has watched, in the atmospheres of those far-off planets around other stars, signs of a kind of slow chemistry driven by starlight, the air itself being changed by the light falling on it, something we had predicted but never before seen so clearly. Each of these is a small door opening, and that, really, is the deepest thing to understand about a great new telescope. It does not only answer the questions we already had, it hands us brand new questions we never even knew to ask. Every one of these surprises is a sign that the eye is working, that it is showing us a universe richer and stranger and more full of life and motion than we had managed to imagine on our own. We built it to confirm what we thought we knew, and instead, wonderfully, it keeps catching us off guard. That is the very best thing a telescope can do. I'd like to pause now near the end and turn away from the stars for a little while, back toward the earth and toward the people. Because it is easy, when you hear about a telescope catching light from the dawn of the universe, to picture the machine alone out there in the dark and forget the most human part of the whole story, which is that it did not build itself. Every piece of it, every golden tile and thin shade layer and careful hinge was dreamed up and made and tested by people, a very great many people, over a very long time. And that, in its own way, is as wonderful as anything the telescope has seen. The idea for a telescope like this was first talked about long before it flew, back when the great telescope that came before it, the one that circles close to the Earth, was still brand new. Even then, some people were already asking what should come next, and dreaming of a larger eye that could see the infrared and reach back to the first galaxies. And from that first dreaming to the morning it finally rose on its pillar of fire was the better part of 30 years. 30 years. Long enough that some of the people who began the work had retired or passed on before it was done, and others who finished it were only children, or not yet born, when it was first imagined. It was built by many thousands of people, working across many years in more than a dozen countries, brought together chiefly by the space agencies of the United States, of Europe, and of Canada, all pooling their skill and patience into this single shared thing. And it was hard. I don't want to make it sound smooth, because it wasn't. There were long delays and moments when the whole project nearly foundered, when it cost far more and took far longer than anyone first promised, and when people wondered aloud whether it would ever fly at all. Building something this new means solving problems no one has ever solved before, and that is slow, uncertain work, full of dead ends and second tries. They had to invent ways to fold a telescope like origami and have it open perfectly on the first attempt. They had to test the whole thing in chambers chilled to the cold of space, to be sure it would survive out there. They had to make a mirror to a smoothness almost beyond meaning, so precise that if you scaled it up to the width of a whole country, the biggest bump on it would be no taller than your ankle. And every one of the 344 ways it could have failed had to be thought about, and guarded against, and worried over, for years, by people who knew there would be no fixing it once it was gone. The telescope carries the name of a man who helped lead the American space effort in its early days, in the years when people were first reaching out beyond the Earth, and it was given his name to honor that early reaching. But the thing itself belongs to no one country and no one person. The mirror was made in one place, the great shade in another, the instruments in others still, in workshops and clean, spotless rooms scattered across the world, each team crafting its own piece to fit exactly with all the rest, so that when at last all the pieces were brought together, they made a single working whole. Picture the trust in that. Thousands of pairs of hands in more than a dozen countries, each one shaping a small part of something none of them could ever finish alone. All of it depending, in the end, on all the rest. Think of the patience in that. To give a great part of your working life to a single machine you will never touch again after it leaves, trusting that all your care will hold up 1,000,000 miles away, in the dark, where no hand can ever reach it. I find that the most moving part of the whole story, more moving even than the pictures, that so many people, most of whom never met one another, gave their careful, unglamorous years to this one shared dream, handing the work along like a torch from the ones who imagined it to the ones who finished it, so that all of us, and everyone who comes after us, could see a little farther into the dark. The telescope drifting out there tonight is not really just a machine. It is 30 years of human patience and cleverness and hope, folded up and sent into space, and unfolded and switched on. When you look at those pictures of galaxies beyond counting, you are also, in a quiet way, looking at what people can do when a great many of them lend their patience to the same gentle purpose and refuse to give up. It took us a very long time to learn to see this far, and we did it together. And so, after all of that, here we are, back where we started, in the quiet and the dark, with you resting softly and the whole long story told. Let us gather it up gently, one last time, the way you might smooth a blanket before sleep. Somewhere above you tonight, a million miles out in the cold and the dark, there is a folded flower of gold that we made and sent away. It hangs in the shadow of a great thin shade the size of a tennis court, chilled to a cold almost past imagining, so still and so quiet that it barely glows at all. And it is looking, right now, as you lie there, out into the deep dark, catching the faint warm light of things unthinkably far away. The light of clouds where stars are being born, wrapped in dust, revealing their newborn suns. The light of planets circling other stars, whose very air it can read from the shadows in a beam of light. And the oldest light of all, the light of the first galaxies, set out toward us more than 13 billion years ago, from the dawn of everything. Only now arriving, only now gathered in, all of it pouring gently onto that golden mirror, a million miles above your pillow, while you rest. And it will keep on doing this for years to come, long after tonight. There are so many more things it is set to look at, so many patches of sky not yet stared into, so many distant worlds whose air has not yet been read, so many clouds where stars are being born that no one has ever watched before. The pictures we have seen so far, wondrous as they are only the very first of what will be a long and patient harvest of light, gathered season after season, while the telescope holds its cold and quiet watch out at its far balance point. We are, in truth, only at the beginning of what this golden eye will show us. There is something I find deeply calming in that thought, and I'd like to leave it with you as you drift off. For all its power, the telescope does nothing but wait and watch and receive. It hangs in the dark and lets the ancient light come to it, patiently, without hurry, gathering in whispers that have been traveling since before the earth was made. It is not grasping at the universe. It is simply open to it, quiet and cold and still, letting the light arrive in its own time. And through that patient watching, we have learned that the sky we thought was mostly empty is full, brimming, in every direction, with galaxies beyond any counting, with stars being born and worlds being made, with more wonder in a single grain of sand's worth of sky than we had ever dared to hope. We are very small and very new, on a little world circling an ordinary star, and we have built an eye that can see almost to the beginning of time. Both of those things are true at once, and together they are, I think, about the loveliest thing there is to know. So there is nothing at all you need to do now. Nowhere to be, nothing to solve, nothing to hold on to. The great golden eye is out there keeping its long watch, and it will go on catching the oldest light in the universe all through the night. whether or not anyone is awake to know it. You can let it. You can let all of it, the galaxies and the newborn stars and the far-off worlds and the patient people who made it possible, drift softly to the edges of your mind and grow dim and gentle and quiet. Let your breathing slow. Let your thoughts go soft and loose and formless. And let the thought of that faraway light arriving out of the deep past into a mirror of gold carry you the rest of the way down into sleep. Rest now. You are held on this small world beneath a sky far fuller than it looks. Sleep well. The light will still be arriving softly when you wake.